All right, this next section, for whatever reason, is not in the book. This is limits as x is approaching infinity. And before we really get into the details of these limits, two really quick things that you need to understand, or at least accept, is the limit as x approaches infinity. If you have any number divided by x, so just, I don't know, I'll just pick a random, let's say 3 divided by x, or x squared, or whatever. But if I have a number over x, if x is approaching infinity, you can't really get to infinity. I mean, what this is really saying is that x is getting larger and 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 larger. And the way I think about this over here in thinking land is basically I'm just going to plug in larger and larger numbers for x. So I'll start with, I don't know, 3 over 10, which isn't very large, but 3 over 10 is 0.3. Let's say I wanted to get closer to infinity, then I would say, okay, let's go a little bit further. Instead of plugging in 10 for x, I'm going to plug in 100. Well, 3 over 100 is 0.03. And I'm thinking, well, that's still not close to infinity, so let's go a little bit crazier. Let's do 3 over 100,000. And 3 over 100,000 is going to be 0.00003. If you punch that in the calculator. And then if you want to go even a little bit closer, let's say 3 over 10 million. And now I'm getting a little bit closer to infinity. And the larger my bottom gets, this fraction is getting closer. Let's see, that'd be 1, 2, 3, 4, 5, 6 zeros, 3, 4, 5, 6, and 3. Okay, the larger the denominator gets, if my bottom gets really huge, 3 over a huge number, the answer, the decimal, is actually getting closer to 0. So this thing, if I plug in infinity, in the world of limits, 3 over infinity, that's going to equal 0. Or any number over infinity, if it's 2 over infinity, or even if this were 3 over x squared, when I plug in infinity, well, that's still going to be getting really big on bottom. So any number over infinity is 0. And also, if you have something like the limit as x approaches infinity of x divided by 3, if I were to flip that, now my infinity is on top. Well, if you think about infinity, and you divide infinity by 3, that's really not going to make a huge difference. That thing is still blowing up. So infinity divided by 3 is still infinity. And any number divided by infinity is 0. So you need to remember those two things right here as we do infinite limits. Those two things are going to show up again and again and again and again. So any number over infinity is 0. Infinity divided by any number is going to be infinity. And I just have 3 problems that I wanted to look at. One of them, the first one is limit as x approaches infinity of this thing. This is what you call a rational function. It's one polynomial divided by another polynomial. And the way we solve infinite limits is we look at the denominator. We have an x squared and we have a 7. And you choose the x, or the term, with the highest exponent. In this case, it's x squared. So what we're going to do to solve this problem is I'm going to take, didn't mean for dots there, all right? I'm going to take my fraction, x minus 3, over, and I left that space there for a reason, x squared plus 7. And we're going to divide every single term. We have x, we have 3, we have x squared, and we have 7. We're going to divide every single one of them by x squared because that was the high power term in the bottom. So I'm going to divide by x squared, divide by x squared, divide by x squared. And when I do that, I get, let's see, 3, or x over x squared, that reduces to just 1 over x, minus 3 over x squared doesn't reduce, over x squared is just 1, plus 7 over x squared doesn't reduce. And now I'm going to plug in infinity, which is kind of weird, and I'm sure Math League of America would cringe when they hear me say plug in infinity, because I'm treating infinity like a number, which is dangerous. But we're just going to kind of think about it. If I plug in infinity, I have 1 divided by infinity, minus 3 divided by infinity squared is still infinity, over 1, plus 7 divided by infinity squared is still infinity. If you square a huge number, you still get a huge number. And all of these number over infinity, a number over infinity, a number over infinity, all of those equal 0. So what this is 0 minus 0 over 1 plus 0. And 0 minus 0 is 0 divided by 1, and 0 divided by 1 is 0. So this limit is actually equal to 0. And again, this step right here, this is kind of fuzzy math. You're not supposed to plug in infinity because you're treating it like a number. and that's dangerous. But for the purposes of this class, that's okay. A number divided by infinity is 0, and that's kind of how we're going to think about it. So find the high power of x in the denominator and divide every term. Going to do the same thing for this one. 2x squared plus x over 4x squared minus 3. I'll look in the bottom, and my high power of x is x squared. So every single term in my numerator and denominator, I'm going to divide by x squared. So I'm going to have 2x squared divided by x squared plus x divided by x squared. Every single term, divide by that high power of x, divided by x squared, and then that's minus 3 divided by x squared. Every single term, divide by x squared. Then we cancel. X squared over x squared cancels, leaving me with just 2 plus this one, x over x squared. One of those x's will cancel one of those, leaving me with just x to the first. So that's the same thing as 1 over x. 4x squared over x squareds cancel. Leave me with just 4 minus 3 over x squared, and nothing cancels. Okay. And again, now I'm going to plug in infinity. Once you clean up each term, I'm going to take that infinity, and I'm essentially going to plug it in. So that's 2 plus 1 divided by infinity. Okay, now remember, 1 over infinity is 0, so that's going to be 2 plus 0 over 4 minus 3 divided by infinity squared. 3 divided by infinity is 0. You remember your 0 plus tables? That's 2 over 4, which reduces to 1/2. So this limit, as x approaches infinity, ends up being 1/2. And one last problem that we're going to look at. This one, I changed it up, and this is approaching negative infinity, but that doesn't change our approach. We're still going to use the same process. We look in the denominator, and my high power term in the denominator is x squared. So every single term, and I have 4 terms in this problem, I'm going to divide by x squared. So x cubed divided by x squared plus 7x divided by x squared over x squared divided by x squared plus 9 divided by x squared. And then we clean up. X cubed over x squared. Well, x cubed over x squared, that's going to reduce to just 1x. These 2 x's will cancel with 2 of these, leaving me with x to the first. 7x over x squared, this x is going to cancel with 1 of these x's, leaving me with 7 over x over x squared over x squared. Those will cancel, leaving me with just 1 plus 9 over x squared won't reduce. And when I plug in infinity, okay, so I have negative infinity, I'm going to plug in for x right there, plus 7 over infinity. Now remember, 7 over infinity is 0. Even though it's a negative infinity, that's not going to change. It's still 7 divided by a huge number, so that's going to be 0, divided by 1 plus, and 9 divided by infinity, that's also going to be 0. So we have negative infinity plus 0 over 1, and anything divided by 1, this answer is actually negative infinity. Okay, so that's the math way of working these problems out. We're going to learn, it's kind of a shortcut, but it's based on memorizing rules where you could just look at these and very quickly say the answer, and I'm okay with you if you can remember the formulas or the rules. We'll talk about those in class tomorrow. Take a quick quiz, and yeah, it's almost Friday. Be happy.